Hey folks, this is going to be the third video for the hyperbolas, and we're going to talk in this video about writing equations for our hyperbolas. So if you can go down to example number 4, we will work through writing some examples, or writing some equations, excuse me. So notice that we have here this standard form, all of this in here. It's a little ugly. So what we're going to do is we're going to factor the leading coefficient out of the y's, factor the leading coefficient out of the x's, and then we'll complete the square. So the first thing that we'll do is just simply factor our 9 and our negative 25 out of the y's and out of the x's. In order to complete the square, remember we did this on the ellipse. So we're going to take half of our b, so that's going to be a -5. We're going to square that -5 and get 25. So we're going to write 25 there in our blank. But when we add to both sides, it's not actually the value of 25, which is going to be written here. It's going to be the value of that 25 times the 9. Because of the order of operations. So for that first one then, let's go ahead and we'll add 25 in the blank, but 9 times 25 is 225. So we're technically adding 225 to both sides. Then we'll do the same thing with the y's. Half of -6 is going to be -3. When we square it, that's going to give us a +9. So in the blank, we're going to have a +9. But this is actually the value of a -25. When you have a +9 times a -25, that's going to give me a -225. So then we'll clean up. We'll combine our like terms on the right side and factor on the left side. So you've got your factoring, and then let's go ahead and divide all 3 terms by 900. We will reduce our fractions. And so here is the standard equation for what we were given. Now, we were told to write the standard equation, so we got that much done. But then there was a couple more things that we were asked to do. We were asked not only to write the equation, we were also asked for the center, and we were asked to determine whether this was a horizontal or vertical transverse axis. So our center is going to occur, sorry about that, our center is going to occur at 3, 5, and then because my y's are in the positive fraction, this is going to be a vertical transverse axis. All right, then some extra examples. On this one, on the next couple, you're not completing the square. You're just taking a list of information and trying to figure out what the equation of the hyperbola is. So this first one, we were given some y-intercepts, so we put those on our graph. And then we also were given the foci. We put those on our graph. And the minute I do this, I can tell that this is going to be a vertical hyperbola. I can tell that my center is going to occur at 0, 0. I can tell that those y-intercepts were not just random y-intercepts, but they were actually the vertices. And they give me my a value of 5. My c value is going to be that 3√3, which is the same thing as the square root of 27. In order to get b, I'll need little dude. And we can plug in our c squared and our a squared to get us a b squared of 2. So in order to write an equation, I need my h, my k, my a, and my b, and I now have all of those things. Remember, this is a vertical hyperbola, so that means that our y's are going to be in the positive fraction. So y minus 0 squared, and I don't need that -0, over my a squared, which is 25, minus x squared over my b squared, which is 2, is equal to 1. All right, very similar concept then for part B. I've got vertices at 0, +5, so you can see those on my picture. This automatically tells me that I have an a value and a center value. My a value is 5, my center is at 0, 0. And then I can start setting up an equation. I'm still missing a b value, but notice I do have my h, my k, and my a. Not only that, I have an x and a y because my hyperbola passes through this coordinate 310. So this is a random xy on my hyperbola. So then let's go ahead and plug in the x's, the y's, the h's, the k's, and the a. So we have y, this is vertical now, y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. You notice that the only unknown is b squared. So just simplify, and you'll get 4 minus 9 over b squared is equal to 1. So we will subtract 4 on both sides. Let me zoom in a little bit here. Subtract 4 on both sides, and then we can multiply on both sides by b squared and divide by that -3. All right, so b squared then is equal to 3. This gives me enough information to write my equation because now I have my h, my k, my a, and my b. So we've got then y squared over 25 minus x squared over 3 is equal to 1. Again, remembering that the y's are positive because this was a vertical hyperbola. All right, so the next one we have is center at 9, -7. So you notice I have that one drawn here. My focus occurs at 9, 3, and my vertex occurs at 9, -1. The minute I see this, I can tell that it's a vertical hyperbola. And I know several things. I know my A value, which goes from the center to the vertex, is going to be 6 units because it's the distance from -7 up to -1. My C value is going to be my center to my focus, which is going to be 10 units. If I know A and C, I can get my B value by using little dude. So we'll plug and chug, and we'll get a B squared of 64. Well, I now have my A, my B, my H, and my K. I have all I need. It, once again, is a vertical hyperbola. So if it's vertical, I need my y's to be positive. So this will be y plus 7 quantity squared using the center here over my a squared, which is 36, minus x minus 9 quantity squared over 64 is equal to 1. All right, one more for writing the equation, this is going to be another completing the square question. All right, so as you look at your equation, the first thing that we want to do is we want to factor a 5 out of the x's, and we'll factor a -7 out of the y's. So the first thing I'm going to do is just do the factoring. After I do that factoring, let's start completing the square. So we'll take half, which is 1, squared is 1. So in my blank, it's going to be 1, but technically I'm adding 5 to both sides. For the second piece, half of b is going to be -2. Squared is 4, so I'm going to be adding 4 in the blank, but technically this is a 4 times a -7, so I'm actually subtracting 28 on both sides. Let's go ahead and combine like terms and factor. Combine on the right and factor on the left. So with factoring, that'll be 5 times the quantity x plus 1 squared minus 7 quantity y minus 2 squared is equal to 35. Let's go ahead and divide all of the pieces by 35. Reduce the fractions. So now I am able to get the center, which is going to occur at -1, 2, which, going back to the directions, we were asked for the center and the vertices. My brain says in order to find the vertices, if I have a center at -1, 2, my vertices are going to be to the right and the left, and they're going to be to the right and the left a distance of a. Now, a squared is 7, so my a value is the square root of 7. So I'm going to go to the right and to the left, a square root of 7. So starting at that -1, we'll go right and left root 7. My y value of 2 is unchanged. And that's the final example for the hyperbola section.